Hello everybody and welcome to the Solving Quadratic Equations video, part 1. In this video we'd like to take a look at how to solve quadratic equations using two methods. So this is our two objectives, and that is the square root method and the completing the square method. We've already taken a look at one method of solving a quadratic equation, and that was by factoring. We did that at the end, I believe, of chapter 6. So we'd like to now expand our methods and our toolbox to solve quadratic equations. So let's just recall in its general form, a quadratic equation is in the form ax squared plus bx plus c equals 0. So we have this generalized trinomial form. So the interesting thing is it's called a quadratic equation due to the fact that the word quadratic is derived from the Latin word, just for those of you that may be curious, quad, quadrate, which in Latin means square. And if we take a look at the leading term here, notice we say ax squared. So whenever we multiply two numbers by themselves, x times x, we say x squared. All right, we don't, or some people will say x to the power 2. But anyways, that's where quadratic comes from and why we call these things quadratic equations. So we would like to take a look at some various forms real quick. So note that anything in the form ax squared equals to h, where a and h are any real numbers, satisfies the quadratic equation. The form ax squared plus bx equals to a number also satisfies this, and the another form of x squared plus bx plus c also satisfies this type of quadratic. So then the question is what happens if the trinomial doesn't factor, or do we have some straight other factoring solving methods to use? So for example, if we have something like x squared equals 144, or we have something as simple as y squared equals 7, or something like x squared minus 12 equals 0, or something like x squared minus 6 equals 25. Notice that these we really don't want to factor. They're not in a form. All right, so the idea now is to use what's called the square root method. So whenever you have a single squared term, the idea is just to get the squared term by itself, to isolate the x squared, and then take the square root. So here we take the square root of x squared is equal to the square root of 144. So the idea here now is that the square root of x squared is going to be x equals, but now we have to go back to the fact that the square root of 144 is not just 12, but rather this is plus or minus 12. So in solving equations, we have to come back to this whole plus or minus notion. So let's note that if I take the square root of y squared is equal to the y square root of 7, then this means that y is equal to plus or minus root 7. Here we don't have the square root the squared term by itself. So notice if we just add 12 to both sides, we get x squared equals 12. So I can go ahead and square root x squared is equal to the square root of 12. So we get x equals plus or minus the square root of 12. And as always, we always have to put these, just like with fractions, reduced form. Don't forget to put your radicals in root form or in reduced form. So x equals plus or minus the square root. So we've seen this a bunch of times already. So this our final answer then is plus or minus 2 root 3. All right, here for our last example in this sort of series, we have x squared equals minus 6 equals 25. So again, if we add 6 to both sides, then we get x squared equals 31. And then note, if we take the square root of both sides, we get x equals plus or minus the square root of 31. As I think about this, I just want to make this mention. What if we had x squared plus 4 equals 2? And notice if we subtract 4 from both sides, I get x squared equals negative 2. And if I go ahead and square root both sides, we get x equals the square root of negative 2. And since we've already discussed complex numbers, we note that this is going to be I square root of 2. And let's not forget our plus and minus. MATLAB will be looking for that plus or minus. And MATLAB will be looking for solving these equations over the complex number system. So I just wanted to make a brief mention of that. We'll see that again. We'll probably see that again here in a minute. So what about something like x plus 5 quantity squared equals 9? So this is something we're going to see in Objective 2 when we talk about completing the square. Again, the idea is that the squared term to the left is already in that form. So if we take the square root of x plus 5 squared, it's going to equal to the square root of 9. So on the left side, the square root and each squaring undo one another, or reverse one another. So on the left side, we just end up with x plus 5. And we know that the square root of 9 is plus or minus 3. So here we end up with x equals negative 5 plus or minus the square root of 3. So as far as I'm concerned, you can stop here, but MATLAB, I've noticed in MATLAB you're going to have to write two solutions. So you're going to have to go minus 5 plus the square root of 3 and minus 5 minus the square root of 3. So I would advise you on the MATLAB to make sure that you read your instructions very carefully on that. So let's take a look at z minus 4 squared equals negative 18. So here we take the square root of both sides. So on the left we get z minus 4 is equal to the square root of negative 18, which we know that 18 is 9 times 2. So notice that we're going to get 3i square root of 2. And I'm not going to get all particular about where the I is located. So clean this up, we're going to get z minus 4 equals 3i root 2. And that should be, then that better be plus or minus. So note that we get z equals 4 plus or minus 3i root 2. And again, these, as far as I'm concerned, you can stop here, but your MATLAB is going to be looking for 4 minus 3i root 2. Probably have to put a comma in there, and 4 plus 3i root 2 or something thereof. All right, so that's the square root property to solve quadratic equations. And note that that method is used when there's not just an x squared term. All right, just an x squared. So our objective 2 then is the completing the square. All right, so this is a technique that will take something that's in the form of x squared plus bx equals to some number h, and then we're going to put this in the form of something like x plus or minus some value k squared, and then it's going to equal to some number m. So we're going to go from this form here, all right, this form here, and then we're going to put it into this form, all right, and then our goal would be to use the square root property. So before we get into the solving part, let's just do a couple of quick things to discuss the actual methodology of completing the square. So again, let's just note if we start off with z squared minus 18z. So now if you were asked to go from this form and put it into, well, we're not going to look at this, but let me get rid of this. We're going to put it in this form. So let's just get rid of, for right now, the equals. We're going to go from this form and put it into this form. All right. So notice to do that, we take this middle term here, and we're going to bring it just over here and do a little side work. All right. So we're going to go negative 18, and then here's what we do is we divide this by 2, which is negative 9, and then we're going to take that negative 9, all right, and then we're going to put it in brackets and square it. All right. So now that means that we come over here and I have z squared minus 18z, and now what I'm going to do is add, and I'm going to put this in brackets. Let me just change the color here. Negative 9 squared. Right. So take the b term, take the one associated with the linear z, come over here, divide that by 2 and square it, and then we're going to add that. And the interesting thing, just to kind of jump right to the moral of the story, is if you take this z and you put it right there, and then you take what's in this bracket to include the sign and put it right there, we have now completed our task. This is completing the square. Again, notice we went from this form and put it into that form. All right. Let's try another one. Let's take a look at a squared plus 10a. All right. So again, we just want to employ our completing the square. So remember, completing the square says to grab this. We're going to just bring it over here. Okay, so 10, and we're going to divide that 10 by 2, and notice that we're going to get a 5, and then we're going to square it. So then we bring this a squared plus 10a, and then we're going to add plus 5 squared. And just like we did up above, we write a bracket, and we're going to bring that a down, and then we're going to bring this 5 down, so we're going to go plus 5, and then we just square it like that. So let's just note that a plus 5 is equal to a squared plus 5a plus 5a plus 25, or 5 squared. So note we get a squared plus 10a plus, and note we get the 5 squared, and that is exactly what we have right there. Okay. All right, so one more practice before we get into implementing this thing. So let's take a look at x squared plus 6x. Okay. And let's just actually go ahead and solve an equation. We may as well go ahead and jump right in and solve an equation. So let's just set this equal to negative 8. All right. So again, as we were saying before, we'll just grab this 6. I'm going to bring it over here, and 6 divided by 2 is equal to 3. And then we're going to go ahead and square that 3. So let's just note that if I go x squared plus 6x plus 3 squared equals negative 8, and notice that what I add to the left side, I now have to add to the right side. Yeah, that's our only little tweak from the other two up above. But notice on the left side, the completing of the square, we get the x plus, and now we just bring down our 3 squared, and that's going to equal to negative 8 plus 9, which is equal to 1. So now we get, cleaning this up, x plus 3 squared equals 1. So now notice this is just like what we had before. Take the square root of both sides. So x plus 3 equals to plus or minus the square root of 1, which is just plus or minus 1. So now we get x equals 3 plus or minus 1. So x equals 3 minus 1 is 2, and x equals 3 plus 1, which is 4. So our answers are 2, 4. All right. Let's take a look at one more. Y squared plus 2y minus 5 equals to 0. All right, so in this case, notice that this is not in this form right here, but notice we can transform this into this form right here by just adding 5 to both sides. So note here we get y squared plus 2y is equal to 5. So now we have this form here, and notice the left-hand side is in the form that we had when we were working with our stuff up here with this guy and along with this guy here. Okay, so notice we'll just come over here and grab the 2 from here. Okay, so 2 divided by 2 is equal to 1, and then we take that 1 and square it. So now I get y squared plus 2y plus 1 squared equals 5 plus 1 squared. So y squared plus, so this factors to y plus 1 squared, and 5 plus 1 squared, so can we see we get 6. So take the square root of both sides, so y plus 1 is equal to the square root of 6, actually plus or minus. So y equals negative 1 plus or minus the square root of 6. And again, for Math Lab, you will write negative 1 minus root 6, comma, negative 1 plus root 6. Okay? Alrighty, so I just got a couple more examples I want to work with you guys here. Okay, for our next example, I'd like to take a look at 4x squared equals 9x. Okay, so again, when we observe we have an x squared and something else, we always want to put this something else involving the x. Put everything to one side. This is going to kind of be a goal for quadratics. When solving quadratics, we like to put everything to one side. So we get 4x squared minus 9x equals 0. Now let's note the difference that we have here, and that is, notice we have this coefficient of 4. So notice, let's just observe up above here that we had here a coefficient of 1, here a coefficient of 1, here a coefficient of 1, and here a coefficient of 1. So notice that in order to complete the square, we have to have a coefficient of 1. So why don't we just take everything now and just divide by that 4. So here I get 4 over 4x squared minus 9 over 4x equals 0 over 4 is still 0. So notice now we get x squared minus 9/4 x equals 0. So again, negative 9/4, so we bring that over here. So notice that we have to divide this by 2. So again, please note that to divide a fraction by 2 just means to multiply by 1/2. We're going to use this technique. And so note that this becomes negative 9 over 8. And again, we have to now square this. All right, so now we have x squared minus 9/4 x plus a minus 9/8 squared. And again, what we add to the left, we have to add to the right. So I got my minus 9/8 squared. And let's just note that this is just 81 over 64. So now this reduces to x, and then I have to bring the minus 9/8 down. Okay, equals 81 over 64. So now if I go ahead and square root both sides, I get x minus 9/8 has to equal to, well, the square root of 81 is 9, and the square root of 64 is 8, and so I get plus or minus that. So now we get x equals 9/8 plus or minus 9/8. So let's just note that 9/8 minus 9/8 is 0, and 9/8 plus 9/8 is 18 over 8, which reduces down to 9/4. So 0 and 9/4 is what we would go ahead and enter into our math lab. All right, so for my last example, I'd like to take a look at 4x squared minus 6x minus 15 equals 0. So again, here we're in our trinomial form as we did before on a previous example. We'll go 4x squared minus 6x equals 15. And again, our leading coefficient here is not 1, so we'll just go ahead and divide everything by 4. Okay, so I think we can agree that 4 over 4 will leave us with an x squared minus 6 over 4x equals 15 over 4. So again, we'll just bring our negative 6/4. Going to bring this over here as 3/2. Okay. So 6/4 reduces down to negative. So we'll bring a negative 3/2. Okay, divide that by 2. So multiply by 1/2. So we get negative 3/4. And note here we have to square that. So now we get x squared minus 3/2 x plus a negative 3/4 squared equals 15 over 4 plus, let's just go ahead and write negative 3 over 4 squared. Just about got it. So this becomes x squared, or sorry, x, bring that x down, and we'll bring that minus 3/4 squared equals, well, let's just come over here and note that this is 15 over 4 plus 9 over 4. Okay, so 15 over 4 over plus 9 over 4. Oops, 16. 9 over 16, sorry. Thank you for catching that. 9 over 16. So here, if I multiply 4 over 4, so this becomes 60 plus 9 over 16, which is 69 over 16. Right? So this just boils down to this right here. Kind of helps. Okay. All right, so we're almost done here. So take the square root. So x minus 3/4 is going to equal to plus or minus the square root of 69 over 16, which is plus or minus the square root of 69 over 4. So now we get x equals 3/4 plus or minus root 69 divided by 4. So again, your math lab will probably want to see this, or just one other intermediate step. 3 plus or minus square root of 69 over 4. So we can write this as 3 plus the square root of 69 over 4, comma, 3 minus the square root of 69 over 4. All right, so that concludes this video. If you have any muddy points or you have any questions on any of these examples, please feel free to share those with me in the warm-up so we can discuss anything about this in class. The completing the square, as I mentioned earlier, is a little bit of a doozy, but it is manageable. But, you know, it kind of helps pull a lot of things together. Outside of that, I will see you in the classroom.